GCSE Physics boosters, volume and pressure. So what is the relationship between the volume of a gas and its pressure? Last video we did pressure and temperature. This is volume and pressure at constant temperature. Look at this apparatus here. It's a syringe, and inside the syringe there is some gas and there is a pressure gauge. So if we compress the gas, we can change its volume and we can measure its pressure. We can investigate the relationship between volume and pressure using this vastly overpriced piece of equipment. And as I'm sure you know, if the gas has a big volume, then the pressure is lower. If the gas has a small volume, then the pressure is bigger. If we compress the gas, then its volume is smaller, its pressure is higher pressure. If you do a graph of pressure against volume, what you find is the graph looks like this. There is an inverse relationship between them. The pressure is inversely proportional to the volume. That means if you double the pressure, the volume is half as much. If you halve the pressure, then the volume is twice as much. There's an inverse relationship between them. They are inversely proportional. Why? Well, assuming that the temperature doesn't change, we'll talk about that in the next video. Assuming the temperature doesn't change, the particles are colliding with the walls of the container. If the volume is smaller, it's going to take the particles less time to get there and back. So they're going to collide with the container more often. So the average force will be bigger, the pressure will be bigger. Here's a relationship you need to know. Now, assuming that the temperature of the gas doesn't change, pressure times volume equals a constant. If the pressure is inversely proportional to the volume, then pressure times volume equals a constant, or PV equals a constant. So if I have this gas in the syringe at P1 and V1, and I compress it so that it's P2 and V2, then PV equals a constant. This is actually called Boyles Law. You don't need to know it GCSE. Boyle, B-O-Y-L-E, after Robert Boyle. Now, when doing calculations, there's a couple of ways you can do it. You'll be given some data, as in you might be given P1 and P2 and maybe V2. And then you'll have to find the other one. Now, what you can do is work out the constant. Then if you work out the constant, then you can say P2, V2 equals the constant and work out the unknown. Another way of doing it would be to say, well, P1, V1 equals P2, V2, and then rearrange that equation to find P2. P2 would be P1, V1 over V2. V2 would be P1, V1 over P2. Sounds a bit tricky, but it's not actually. Here's an example. Now, you can have a go at this. The gas in this syringe starts with a pressure of 100,000 Pascal, which is about 1 atmosphere, and a volume of 0.005 meters cubed. And I know that's 5 liters, so it's quite a big syringe. Now, if its volume is reduced to 0.003 meters cubed, what will the pressure be? Have a go yourself. I'll show you the answer in 3, 2, 1. There you go. So what I've done here is I've rearranged the equation. So P2 is P1 V1 over V2. I've substituted in the numbers. Always do that after you've rearranged the equation. And there's my answer, 167,000 Pascal, 1.67 atmospheres. Here's another couple of examples you can have a go at. I'll show you my answers in 3, 2, 1. There you go. So in the first example, I've actually worked out the value of the constant, and you get 800. And then I've said, well, V equals the constant divided by P2, and I've got 0.008 meters cubed. So we've gone from how many litres? 2 litres to 8 litres. One way of looking at it, by the way, if the pressure is a quarter of what it was, so the volume must be 4 times bigger. In the second one, I've done my P1 V1 equals P2 V2, and I've rearranged it for V2. I've substituted in the numbers, and I get 1.5 meters cubed.